Hello, ladies and gentlemen. We will be looking at why cloud security posture management or any visibility tools that purports to provide protection in your cloud environment may be putting you at risk because you may actually not be seeing or blocking attacks that are occurring in your cloud environments. So what you're looking at right now is the AquaHub platform, and we will start with CSPM. The reason we're starting with CSPM, Cloud Security Posture Management, is because it can connect very quickly to your public cloud environment. Let's take a look at our AWS instance in this case, and we can see that we are doing very well from a security posture perspective. We can see that over 6,000 checks that we are doing to check things like misconfigurations that could potentially lead to an attack. I have done very well, we passed. And if we look at compliance and look for particular regulatory compliance, things like PCI, we are 90% compliant. Let's take a look at GDPR, we are 93% compliant. And something like FedRAMP, we are 99% compliant. So from a risk posture and visibility perspective, we are doing very well. It looks as if our public cloud has been configured correctly. Let's jump into another module in the AquaHub platform. We're taking a look now at the AquaHub. And AquaHub allows us to have very holistic visibility across my entire cloud estate, whether that's Kubernetes, VMs, containers, functions, etc. So if we look at the inventory tab over here, we can look for a specific risk or particular vulnerability. Let's take a look for log4j, and we can understand immediately which environments or where in my cloud estate am I potentially exposed to the log4j vulnerability. We have some Lambda functions here. We have some images that contain this vulnerability. We can also look at insights. This is a great way to look at things like compound risk. So for example, do we have workloads with excessive privileges to cloud resources that have exploitable vulnerabilities? And here, if I click on this, we can see that we do indeed have some Lambda functions that are posing some serious risks here. Or we can take a look at another one here where we have workloads that have privileges to cloud resources with a critical severity vulnerability and a network attack vector, meaning they could potentially be remotely exploited. Now, this is great. We can look at the reports. We have specific reports, whether it's trends reports, that are all really important in terms of visibility and risk posture. What all of this is not doing is stopping attacks. It is not preventing a breach in my organization. And to understand the extent of that and what is the risk, we will jump into our workload protection module. And what's interesting here is the contrast. So whereas we saw from a risk posture perspective, everything is green. We're compliant with PCI and GDPR and FedRAMP. We don't have any misconfigurations. However, in the very same environment, we have active malware, which is currently running from memory within a container in the same environment. So you can see here that we have a fileless loading ELF that's being written straight into memory and has been executed. And we are detecting this using our cloud workload protection module. And I can come and understand how did this attack occur using the timeline view. So if we look here, we can see that a rogue container was deployed. We can see that a new executable was dropped to memory during runtime in this container. And then we can see that a fileless execution was detected from memory. And the nice thing about this is beyond the ability to do forensics and retrospective analysis and understand how the attack occurred, we can also look at the raw data and provide this to our security analyst team so they can really understand and delve into the details here. So it's one thing to be able to detect these kind of attacks in runtime, in my workloads, but let's see how we actually block these attacks as well. So if we look at, let's take a look here and look at some of the critical alerts that we have, we can see that we have malware detection that was blocked. And we see it both at the VM level as well as the container level. So let's take a look here and we can see that the malware was blocked in this particular container. And we can see that it's mapped to MITRE attack framework using defense evasion, everything that would be really important for a security practitioner to know. And the reason that we can block this is because we have runtime policies specifically designed to not just identify these sophisticated attacks, but also block the attacks. And we have a runtime policy here, as you can see, that says block known and unknown attacks. And I'll just emphasize that we have these policies both at the host level, container level, and function level. So let's jump into the block known and unknown attacks policy. And we can see here things like block crypto mining, block fileless execution, which would have prevented the malware we just saw, block reverse shell. And we also have advanced malware protection. This is really important because it prevents known attacks, even if they are running from memory, as we just saw. But you may ask, what about unknown attacks? And that's where drift prevention comes in. Drift prevention is really helpful because it enforces immutability throughout the life cycle of this workload. So once the container has been instantiated, any payload that is executed that was not part of that original image will be prevented from running, significantly reducing any risk, but also minimizing the operational overhead. And that's what drift prevention does. So what we've seen here is, on the one hand, we saw cloud security posture management and how we can connect to our cloud environments, providing time to value and immediately understanding the risk posture. We looked at AquaHub to see how we can look at our inventory, look for specific vulnerabilities across or risks across our entire cloud estate. We saw insights and compound risks and then looked at some reports. However, all of that provides visibility and risk posture. What it does not do is actually block an attack from occurring in the very same environment. And that's when we jumped into our cloud security, cloud workload protection module, and we saw how we actually have an attack going on in the very same environment. And we looked at some of the runtime policies that can block these attacks and alert us to them when they occur.